Welcome to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. Joining me today is Andre Alcalde, co-founder of Celis, to discover the very hot topic of AI and PCB design. For those of you who follow us on LinkedIn, you may have seen our recent host live session with Andre and one of our own AI experts, David Waynes. We really dove into the topic of AI and PCB design. I was unfortunately unable to join that session, so I'm excited to chat today with Andre. Thanks for being here.
Thanks for having me, Steph.
Can you describe or give a background of yourself?
Sure. So my background is electronics engineering. I've been working for the last 15 years in the industry. I've worked with component manufacturers as a product engineer, for instance, helping them bring new components to the market, creating the data sheets for their products. But I've also worked in the industry as a hardware designer myself, where I designed then power supplies for high reliability applications. In 2018, then I met my two other co-founders, Tobias and Alexander. That's the point where we started Celis. Right now, under other responsibilities, I'm dealing mainly with our research projects, scouting different technologies, for instance, AI, finding applications of those technologies in our specific field, and then working with our product development team to bring them to the market.
That's outstanding. You know what I love the most of your background is that at the core, you're a hardware design engineer. So that means that you understand feeling that pain through the process, and you have now implemented that within Celis of what you're doing, and you guys are doing some amazing stuff. There are a couple of things that I think that are important to cover for our listeners here today. Let me ask this, AI seems to be everywhere today. Do you think it's a passing fad, or is AI here to stay?
AI is here to stay. I think that it has such a transformational nature, and it's already helping a lot of people on the most varied tasks that we can think of. We see the advent of the LLMs that are in the market today. Anyone can create an account and start using them, for instance, for text generation, for the generation of graphics. It's already very, very useful. So it's already saving the time of a lot of people and empowering them to do things that they would not be able to do before, or it would take them a lot of time. And I think that this is just going to, penetrate in different industries right now, like we're going to discuss today for electronics engineering, especially. I think that this is not disappearing anytime soon.
When you think about the core processes of AI, to what extent can AI fully automate PCB design processes, and what tasks are likely to remain manual? When you think about AI and what can you automate, and then from the manual perspective?
Yeah, always when I think about automating or fully automating, I always take it with a grain of salt. If we think on the electronics industry specifically, I like to always go back to an analogy that is the analogy of digital design for integrated circuits. So how that actually started and how that evolved over time. If you look back in the 70s, digital design for integrated circuits was something that was done mainly manually. So we had engineers dimensioning every transistor. They had to manually draw the layout for that integrated circuit, draw the masks for that. And with the advent of technology and the fabrication processes evolved over time, that was then shifting towards more automation. So they were looking then for tools that could automate those parts of the work, because it was getting more and more complex for them to handle thousands of different transistors within a specific design. And the way that actually this evolved over time is that with those technologies, with, for instance, synthesizers and place and route algorithms used in this integrated circuit industry, engineers were able to focus more and more time on the definition of more complex systems, and also the validation of what was created by that specific automation, which was not AI-based, but still very, very design rule-based, but still an automation, right? That would take, in that case, VHDL or Verilog code description of the system, and would transform that into RTL or directly into the layout files that that are necessary for fabrication. So a lot of the time that engineers usually invested on the design of transistors and on the routing of those logic gates shifted to the complex part of defining, those more complex systems, and also validating those systems in the end. So how do you validate that? You cannot look into the schematics and check, if all the transistors are connected correctly when you have billions of them. So simulation then started playing a more important role. And I think that for when we're talking about PCB design, I think the trend is going to go very similar to that, as we have automation based on AI in this case that will help engineers designing more complex PCBs. We'll have more time from engineers being put into defining those designs, more complex designs in this case, and also investing more time on validating those designs in the end, because you cannot anymore do an analysis by just checking the circuit. You would probably have to simulate it to see if it behaves as you want, instead of checking every specific component in that design.
When you think about the complexities of today's designs, you've got to do your due diligence, from simulation to analysis. It's not like in the days past where we can get away with just designing the board and doing that type of stuff and then pitching it over the wall. And then you get into the lab, you can just start testing it. It's those days are gone. Now you've got to do your due diligence. You've got to do it up front, and utilizing the tools today, utilizing that automation. And now with AI coming into play, I think those engineers that take advantage of that and use it when they can, where they can, to their advantage, it would allow them to be more innovative and be a better version of themselves as an engineer to produce a better quality product in a shorter amount of time. And when I think about automation, I think about not so much as when things are going right, but when the project gets tough and you have to make changes on the fly. How quickly can you adapt to the change and recover and still go forward? That's what I think about AI, and our evolution of where we're going. I noticed, there were on that LinkedIn Live session, there were a couple of questions that came up during that session around protecting IP. So let's revisit that as well, since it seems that it really resonates with our audience. What are the challenges do you think exist to ensuring data privacy and security when training AI models for PCB design?
Yes. I think that is a very, very interesting question, because now we're not just talking about personal use, like people personally use ChatGPT, but we're also talking about company IP, right? Many companies that are designing electronics, they want to keep their IP, they want to keep their data because it's part of their competitive advantage as well. So if we look at the large language models in the market today, they are trained on vast amount of data that is available over the internet, be it Wikipedia or news. There is a lot of information that is freely available in those generic fields. But for PCB design, that is not the case, right? The amount of data that we find that is open source is very, very limited. Definitely not enough to train a model from scratch that is able to do a good electronics design, good PCB design as well. So it's definitely a challenge for the industry. So how do we actually get models that can understand designs, that can help engineers on their tasks, if we don't have enough data to train them that is freely available? And I think that here there's probably a hybrid approach that is the most suitable for this case, because we can think of not training models from scratch based on PCB and electronics design data, but we can think on pre-training models by giving them information on how electronics design actually works. So that could be, for instance, specific design rules, the same type of information that would expect an engineer to learn through their university grade. This is the type of information that can be used to pre-train a model so that the model understands the basics of electronics design. It may not know specifics on an industry or specifics from a certain company, so how the company approaches PCB design, but it can learn the basics of electronics design. And this model is something that can be made, let's say, as a baseline available. And then when we think about companies using AI for their specific internal tasks, where they don't want actually any data leakage, any information that gets outside of the company, then we can think on those models being fine-tuned using the information that the company has. And that specific fine-tuned model is just available then for the company itself. So it's almost like taking the baseline model that is available, for everyone, teaching this model specific things from the company using specific data of that company. So the model would learn how to, use design rules of the company on the specific field where they're operating, be it automotive, be it consumer electronics. then it depends on the company. And that version of the model is then just available for the company. And this model can be used still on the cloud, just like other services are today available for enterprise on the cloud, but it's still on a closed environment. It could be, for instance, deployed on a cloud provider such as AWS, Azure. There's many of them out there now. So this model is then closed for the company. It knows how to handle design information of the company. It was trained based on the data of the company, may also access data of the company, but it's in a closed environment, only available for the company and its employees.
That's great, because when you think about a lot of the Mil-Aero type companies that, well, I guess not just Mil-Aero, when you think of any enterprise level company, that company IP is everything. And how do you protect that? How do you keep that within the company? And a lot of people are hesitant when it comes to AI, cloud-based. It's like, where's my IP going? Is it going to be shared? Is it going to learn off my models or my content and then shared with the world? Companies are hesitant to even approach that because they feel they're going to lose their competitive advantage. At least that's my understanding, or my gut feeling.
When we started, for instance, 2018, when we talked to companies, it was a very different approach there. I think a lot of companies were still using their own servers, and a lot of the cloud was still coming up. Nowadays, it's different. Many companies already migrated their infrastructure to the cloud. They're using Microsoft Azure, they're using AWS to maintain their data, to maintain their software infrastructure as well. So that mindset already changed. But still, a lot of people want to know, when we're thinking about training models, what is the model actually extracting out of my data? So if the model is then limited to the company scope, then these preoccupations, or these risks, they are mitigated.
When I think about not just, getting your models and training your models, I want to step back. So I want to talk about the workforce in this regard, and how is AI changing the skills required for PCB designers and electrical engineers when you think about the evolution of not just the tools, but the evolution of the mindset and the skill set as we go forward?
So I think a lot of the focus will turn from doing specific tasks, is going to shift to much more to being able to analyze results, being able to constrain the problem so that the automation, or the AI in this case, is able to understand exactly what is it to be done. Instead of, for instance, looking for data sheets on the internet and trying to interpret what they mean, or trying to find information on that specific data sheet, is going to shift much more to, I have here many different solutions now for my project. There are many components, there are many different topologies I can use. How do I evaluate the trade-offs here, between these different solutions? I think it's rare to see still nowadays that an engineer has a lot of designs and they have to evaluate trade-offs there. It's much more that they have maybe to evaluate different components, because they have very limited time to actually put in designing 3-4 different variants and then testing which one is the best to work with. But I think that the time is probably going to shift in that direction. Also, as I said before, how do I constrain my problem? How do I really describe what I want to do in a way that the automation can understand that, in a way that is not ambiguous? So for digital design, for instance, that is the point where description languages such as VHDL or Verilog came up, because they're really good for this specific purpose. And in the end, also of the process, evaluating. We got something, it was generated. I cannot evaluate, I cannot analyze it by hand just because it's too big or too complex. So how do I simulate? How can I verify that this is going to work for my specific case? So I think in this specific context, AI will allow us to deal with more complex designs. It will tackle complexity for sure. And the time then is going to go much more, and the skill sets, are going to migrate much more to the point on how do I actually define my problem or my constraints or what I want to build. How do I verify and evaluate this in the end in a way that I'm sure, when we move to production, that we won't find a bug in a later point in time.
You made so many good points in that response. And I would tell you, when it comes to the engineers and designers and their skill set and how they utilize their tools, that especially going forward with AI, and how they're going to use it to their advantage, will make a big difference. And like I said before, those that embrace it and that will use it to your advantage, I believe will achieve much more, significantly much more success than those that don't. Don't get me wrong. I think they'll still have success, but it'll take them a lot more effort and more time to be able to do it or to achieve that success. Whereas with AI and using it to your advantage, time and quality of product, giving you different variants and different versions of an output that you can then evaluate very quickly and say, okay, this is going to be the best solution for us. When you think about the give and take of all the different decisions that go into electronic system design. So when you think about AI, will you see AI to reduce or increase job opportunities in the PCB design field? And how can professionals future proof their careers when you think about the evolution of design and everyone's, oh, I'm afraid AI is going to take my job. I'm not going to have a job. So what is your take on that?
I think it will definitely increase. If we think on electronics industry itself, today, we know that there is a huge demand for smarter devices. Everything needs to be smart, connected. So I think even today, if I think on the context of Europe, where we are right now, we already have a huge skill shortage here. So different companies, they are not able to find actually professionals to meet the demand of the market for new devices. So I think on one side, AI will bring a little bit of relief on that sense. But as I said, it's not going to be like AI takes specific tasks that engineers are doing today, and then there is no task anymore to be done. I believe much more that there will be the skill shift then. People will start focusing much more on, now that AI is doing this, we can actually, we can put a little bit more complexity in this and we can get a better product in the end. We can optimize it a little bit more. So I think that the complexity of the devices that we see out there, it will increase over time because AI allows us to deal with this complexity, by automating part of the design. As the demand also of smarter devices increase, I think the demand for electronics engineers will also increase. So I don't see that going down. If we think on the analogies I mentioned before, semiconductor industry, software industry, we saw exactly the opposite. The more automation, the more complex things actually got, but the more value we can bring to everyone out there, to the society. So that actually just increased the demand for this type of professional. So I think that is going to go the same path as well.
Still, when we think about AI and its evolution in industry, there's still resistance. So let me ask you this. Why do you think there's still, reluctance to adopt AI-driven solutions?
I think a lot comes also from expectations. When we talk sometimes to users, a lot of people have the impression or the expectation that AI is going to provide them with the correct answer always in the first time. And I think we're expecting then too much of a system. We're expecting perhaps more from this system than we would expect from an experienced engineer in a sense. I think that if we start looking from a different perspective, AI is not there to provide me the right answer right in the first time. It's there to help me understanding some of my constraints and help me to get different variants for my design in a quicker way than I could if I would do it manually. Then I think this mindset starts shifting a little bit. We have to remember that every AI system is trained based on data. The pattern we're looking for may not be represented in the data set that was used to train it. So we should not blindly trust the outputs of AI, but we can use this to augment our capabilities, of generating variants, of thinking out of the box, perhaps giving us ideas that we're not even considering because we are biased. Also, we are biased based on our experiences. And I think that once we take this, we put this different hat, then these expectations, they change a lot. It's not anymore the expectation AI is going to do my job in the first time right, but it is much more AI is going to help me actually achieving a more optimized solution. So it's more like a collaboration between the engineer and the AI and not necessarily, I just give away everything I do, all my responsibilities to AI. And if this is not the case, then I should not trust AI at all. So I think that the perceptions are probably going to shift still over time towards this direction. When people see, AI is not there as an oracle, is not going to give you the right corrections or the right answers first time right, but is there to support you on finding those.
Behind the scenes when you're talking, I'm like clapping internally. I mean, and cheering because I couldn't agree 1,000% of what you just said. It will just allow you to be a better version of you to produce a better quality product and give you the opportunity to come up with different scenarios and try things that which are very complex that maybe you just physically don't have enough time and your resources available to be able to do that. And harnessing that and embracing it and using it to your advantage will be the key. Your response summed that up. I love it. I love it. And honestly, I could talk about AI forever and keep going because I truly am a huge advocate of automation, which then evolves into AI. To me, I see those as being very similar. And when I think of the topic of AI, so let's close this out with a couple final questions. How do you see AI improving design iteration cycles, and what impact does this have on time to market for new products?
If we have a process that is more based on defining a specific problem or constraints of the design we want to do, then we have some kind of automation based on AI that is able to take that, generate, for instance, an architectural design, generate schematics, generating, for instance, even PCB layouts. And then we can evaluate that in the end by using simulations. Then we have here a basis for a process that is much more straightforward and perhaps less artistic than the process that we have today, but is much more streamlined. This process is in a way less dependent of the engineer that is working on the project. So today, if we think on a design, you can give requirements to different engineers. They will come up with their versions of the solution that is based on their experience. So more experienced engineer will perhaps have a more elegant solution. Less experienced engineer will perhaps need more time, not reach the optimized design. And then when we think about the streamlined process that AI in this context allow us to have, it's much more independent then from the engineer that is working on the project, and is much more interactive because you can go then from beginning, from the constraint, you can fine tune a constraint, you can regenerate an output, you can run your simulations or validations on top of it, and you instantly see then how many of the test cases are pass or how many of the test cases are fail, and then you can iterate quickly over that. I think that you have a more agile approach than for the design. You can iterate quicker over it, and then you may produce then your board when you're confident that that board is passing all the task cases, and then once the results of the lab, you can maybe bring it back on the constraints. You find something new, you can bring it back to the constraints. But I think it's a more streamlined process. And I think that because it's a more streamlined process, follows again, maybe the analogies I mentioned before as well, and it makes it quicker to bring new products to the market.
I agree with you. I think speed and quality is everything. How fast can you do it? And at the same time, do it with the highest quality possible and deliver the best product to market. And, the window of opportunity sometimes is very small. A lot of these small businesses, their time to market is yesterday. Improving the design iteration cycles is key. And how do you do that? And I think AI is the way. With that said, getting time to market, and you think about all the difficulties and the challenges which you covered in the first part of this podcast. What are the risks versus rewards of using AI tools in PCB design?
One of the risks I previously mentioned is having this mindset of blindly trusting what AI is generating without really evaluating or without really verifying what is being put out. And I think this is a risk because we know some models are more predictable than others. We know the issue of hallucination, for instance, when talking with LLMs. You can see sometimes they can give you a very convincing answer, but if you read it, you know that it's not true. But they can be very convincing in that sense. So I think understanding which models are you actually dealing with? Are you dealing with more predictable models or less predictable models is one way of mitigating this risk. I think also we cannot just make all the models being always very predictable, because I think we lose then one of the biggest rewards, in my opinion, that comes together with AI. The fact that they are able to give us new and very creative outputs is also kind of a trade-off with hallucinations. So if we make them all very predictable, we're just reproducing also our way of thinking. But I think finding new solutions for existing problems, thinking a bit out of the box, is one of the rewards that AI has to offer. So I think that the best mitigation is actually understanding with which type of model are you actually working, what should you expect out of it, and also validate what comes in the output. If we're able to understand those limitations, deal with them, then I think we can extract the best out of it. Clearly, the rewards there, they overcome the risks, and then we are able to make electronics design faster, better, in a fraction of time. I think that this will just benefit, society by allowing everyone to have more complex and perhaps more satisfying products being brought to the market in the end.
Well stated, well stated. And I will tell you, in my opinion, when I think about risk versus reward, what is the cost of doing nothing and staying status quo and continuing using a legacy approach, trying to attack today's complex designs? That's the risk of doing nothing and potentially getting left behind or outpaced by your competitor. You and I can talk all day, and go on forever, especially with our friendship here. So let me ask you this: is there any last words or any last things you'd like to close out before I close this out?
What I can say from my side, AI is going to bring a lot of innovation to the industry of electronics design. I think that a lot of the things that we saw coming up on other industries still didn't make to the PCB design industry yet, because of a lot of difficulties we have on dealing with all the vast diversity of components out there, all the very complex design rules. So I think AI is one opportunity of bringing the industry really to a new level of dealing in a better way with all the data that we know exists out there, and empowering engineers to be more effective, efficient, produce better designs in the end. But also closing, as I said before, there is a huge skill shortage in the market today. So if we do nothing about that, I think it's going to be, pretty soon that we'll have a limitation or a cap on the complexity of designs that we see or the amount of new products brought to the market. With AI, I think we can unlock that. We can unlock real economic value for all companies producing and willing to produce smarter products. From our side, from Celos, we are working mainly on the part of helping engineers to go from a architectural design to their schematics and the bill of materials. We're employing machine learning and AI to do that as well. We hope that this also unlocks value for all the users out there.
Awesome. Andre, I want to thank you again for joining us today. And thanks to our listeners for tuning in. Join us on future episodes exploring trends, challenges, and opportunities across the printed circuit engineering industry.